basically, what the first thing I'm looking for is, do you know that it's basically the integral of the density function over the relevant region? And next is, can you actually integrate it? And I won't give you anything that complicated. So.
Would you say you look for the relevant region of the integral?
I'm sorry, say that again.
The relevant region of the integral.
And I can say that again. What lower integral region?
The relevant region of the integral. He means the limits.
So the relevant region of the integral. Yeah. So basically, here the relevant region is the region where x plus y is between 1/2 and 3/2. Okay. So you can write this down first, and then for this problem, when you actually put in the density function, set it up like that. So just going from here to here will give you most of the credit for the problem. Okay. The rest is calculation. You definitely get some credit for calculation and calculating it right, but this will count for most of the points. Can you set it up right? Do you know what I'm asking you to do? That the probability of this is basically the integral of the density function over the region that I'm interested in.
So if we're running short on time, set it up and come
Definitely
back
set
to
this
it.
right, exactly.
Yeah. Okay.
So set it up, calculation, you can leave for later. I mean, they will count for something, but not as much as setting it up, right? Okay. All right. Okay, so problem 2, the capacity of an elevator is 2,700 pounds. If the weight of an athlete is normally 25, 70, all right. So let xi be the weight of ith athlete. And how many athletes are we talking about? 12. So you have I athletes, Xi's are their corresponding weights, and I can just assume that they're independent. Okay? So if you don't think it's obvious, then you state, assume Xi's are independent. Okay. The other thing I know is that each of these Xi's, I told you that the weights of athletes are normally distributed. So it's with mean 225 pounds. Okay, weight in pounds. 225, standard deviation is 25. Remember, I'm always putting in variance at this point. So it's 25 squared is my variance. Okay, so if they're each normally distributed, and I'm assuming they're independent, then the question is asking me about, so set up your question. Your question is basically, is the sum of these weights, the capacity is 2,700, so that's basically the question. So this is the probability that they can get into the elevator. So once you set up the question like that, you need to figure out then, do you know something about the distribution? You're asking a question about the probability of summation of xi's. Do you know something about the distribution summation of xi's? Now in this case, it's not just a question of an approximate probability, you can find the exact probability because you know the exact distribution of a sum of normal independent random variables. Okay? And we know that 12 xi, the independent, will be normal, their weights would add, okay, and each of their weights is 225, so it just be 12 times that. This is times 12. And their variances would also add up. So it's 25 squared goes at 625, right? So we know that this is distributed as normal with mean times 12, the variance times 12. So all I've used here is summation I equals 1 to n xi. These are each normal. It's distributed as normal. Summation I equals 1 to n. Mu I say if xi is normal. Mu I sigma I square. Xi is independent. then this is what I know about their variances. Means add, their variances add. So standard deviations don't add, the variances add. So that's all I've used, and now I know exactly what the distribution of summation xi is, and we know how to calculate probabilities if something is normally distributed. So probability that summation is 1 to 12 xi is less than 2700 is the probability that summation I equals 1 to 12. So this is basically now material from the second midterm. So what is 225 times 12? You will need your calculators for this exam.
2,700.
2,700. And okay, divided by so this the square root of 12 times 625. So what is 12 times 625?
7,500. So it does
7,500. Okay. And so I'm looking at the probability of this list at 2,700. 2,700 over. Yeah. So this is not an approximation. It's now exactly equal. With normal distribution, you normalize it. It's exactly equal to the standard normal, less than 0, and that should be 1/2.
That's convenient.
Okay.
At the point that we saw that we were asked the probability that it's less than the mean, could we just say 1/2 since you're not so much?
Oh, well, yeah, so actually at this point, right. Yeah, so, I mean, he brings up a good point. In this case, we know that this is normally distributed with mean 2,700, and we're asking about what's the probability that it's less than the mean. So we know for a normal distribution, you're symmetric about the mean. So the area to the left of this is 1/2, the area to the right of this is 1/2. So you actually, at this point, if you know that this value is 2,700, then yeah. So then you would always, but this your problem may not always be that it's exactly the mean they're asking. But I know it's 1/2 because to the left of mu is 1/2, to the right of mu is 1/2. All right. Now, if it wasn't 0 here, or say if it wasn't 2,700 plus some other number, you know you've got to check the normal tables. And I'll provide normal tables. And that is why you normalize so that you can convert it to standard normal, and you only have tables for your standard normal. Problem 3. As a joint probability density function, zero otherwise. So calculate the correlation coefficient of x and y. Now, at this point, if you notice something right away, it makes the whole problem really easy. Makes it a one-line answer. And that is if you realize that x and y must be independent. And that's basically from this theorem that says if your joint density function can be written as a function of x times a function of y, then you know they're independent. Okay. So you say x and y are independent as f of x y is equal to g of x times h of y. Can be written as g of x times h of y. Or you can say it's of the form. Is of the form g of x times h of y. So you can take g of x to be sine of x when x is between 0 and pi over 2 and 0 otherwise, and h of y to be sine of y when y is between 0 pi over 2 and 0 otherwise. so and then since x and y are independent, covariance of x, y is equal to 0. That is it. Now, if you didn't know that they were independent, you would have to use this formula. So that means calculate the covariance, calculate the standard deviation for x, the standard deviation for y. And this would be a computationally intensive problem. Alright. So you need to know your formulas for covariance, variance, mean, etc.
With what you're erasing right there, with that problem, where did we get the negative half and positive half? So we knew that it was just,
Negative half.
Oh, never mind. I'm saying the wrong thing.
They're both positive.
I didn't, but a half?
Yeah.
Oh.
Because it's symmetric with
just-
respect to mu.
Yeah, okay, so let me just talk about that.
But we were going from some place to someplace else, right? Integrating?
No, we're looking
Or
at the
summing.
probability that some random variable is less than its mean. And if y is...
Okay, it doesn't matter where it's going from. Okay, I got it.
Yeah, so it is normally distributed, the probability y is less than mu is just asking about this area. And this area is always 1/2.
I have a silly question, guys. How is covariance related to the correlation coefficient? Oh,
This is the formula.
thank you very much.
So that should be on your formula sheet if you have memorized it.
Yeah. Okay.
And they ask for the correlation coefficient. Oh, there's something I wanted to mention. Correlation coefficient is only defined when your variance is not 0. Okay? If your variance is 0, then one of them is a constant. So you don't talk about correlation coefficient. You can still talk about covariance, but this would then be undefined because then you have to divide by 0. This, neither of them is a constant, so you can talk about correlation and correlation. Yep, A, X, and Y, from the function. So your density function is
Oh, I'm sorry.
That was another.
find the condition density that. So we're first going to find condition density first.
Yeah.
Condition density X given. So they've asked you to find this. This is just defined as joint density divided by density for y. So you don't have this as yet, so you first need to calculate that. Find just the marginal density for y. So that's just integrating out your x. So you integrate your x from 0 to 1. That's joint density. So when you integrate out your x, what do you get? So 1/2 plus 3y squared over 2. So your conditional density is maybe at this point you should say for already you know when y is outside this interval, your density for y is 0. Alright, so condition on y being between 0 and 1, this is your joint density. You can talk about joint density when y between 0 and 1. And let's write that down, so 3 over 2 is y squared over 1 plus 3y squared over 2. So that cancels out to 3x squared plus y squared. And 0 when x is outside the region. If I don't mention anything else, it means it's 0 outside that region.
So we just mentioned x because y is fixed, correct?
Yeah,
We
and
don't
y
have
is
to-
fixed at some point between 0 and 1.
Okay.
It doesn't make sense to condition on y outside of that.
Okay.
Yeah, so you only mention x here.
Okay.
So this is now defined for,
Okay.
so that's the density function of x. And now find the expectation. So let's first find this. It's just the integral of x. So that's the formula. Let's integrate. So it's going to be x 1, 3 x squared plus y squared over 1 plus 3y squared dx. As you get with respect to x, so your y is treated as a constant, so I can pull this 3 over 1 plus 3y squared out. So 1 have x cubed plus xy squared. This equals to 1 plus 3y squared, integrating actually 4 plus x squared over 2y squared. And you can see 1 plus 3y squared, 1 4 plus y squared over 2. So the answer is 3. That gives it 3/4 plus 2y squared. So a conditional expectation. Okay? So once you have conditional expectation, you should no longer have x in the picture in this function of y. Since I asked what is this, so if I write little y as capital Y, I can just write this as 3/4 1 plus 2 capital Y squared 1 plus 3.
Where did it, I followed you up until, no, further. The third line. Yeah.
Here.
What happened between those two?
I just took common denominator here. 4, so 1 plus 2y squared.
Oh, yeah, okay.
And the rest remains the same.
Okay.
And it's 3, 4, or 3 and 4. Okay. So this is like, if I know that my y takes the value little y, what is the conditional expectation of x? Gets the function of y. If I don't know what y is, but I say if I condition on the value of y, whatever it is, the expected value of x is, so it depends on what the value of y is.
Now, if they gave us a value of y, we could plug that in.
Exactly, yeah.
Okay.
So if I ask you what's the conditional expectation of x, conditional y equals 1/2,
We'd solve for the conditional
so you would
expectation with
plug
y
in,
equals
yeah,
y.
so you plug in y equals 1/2 of that.
And then plug them in
Yeah.
there. Okay.
So you'd end up with a number then.
Okay.
The So you have an electronic system, so X is the lifetime of the electronic system, Y is the lifetime of one of its components. So if the electronic system dies, that particular component could still be working. So but of course if the component dies then the whole system fails. So your X is always less than or equal to Y. And the first question asks you to find the expected value of the lifetime of the component when the system dies. So when the system dies, the remaining time is, so Y is the lifetime of the component, Y is always greater than X. So this is the remaining time, right? So once X dies, Y is greater than X, Y minus X is the remaining time. And I wanted the expected remaining time, so I wanted this value. So it's an expectation of some function of X and Y, so I just integrate this function of X and Y, which is just Y minus X with respect to the density function. Plug in what is the joint density. Given the joint density is 49. So X is from 0 to infinity, and Y. Okay, so this is just Y. Yeah, that would be something. Let me write down the joint density function here. 49 negative Y over 7. Okay, so let's take Y going from 0 to infinity, and X then is everything less than Y. So X goes from 0 to Y. And then we plug in your density function, 7. So X goes from 0 to Y, the X is Y.
Could you break it up and find the expected value of Y minus the expected value of X?
Yeah, you can do that. But I don't know if this will necessarily be simpler or not. But yeah, you could write the expected value of Y minus expected value of X.
Okay.
After that, okay.
Fine. Okay.
So, but again, it would involve, if you want, you can find the density function of Y,
You can find
the
the
density function of X.
X.
Or basically write it like this, distribute this over Y minus X, and essentially the same thing.
Okay.
Okay, anyone has the answer to this?
7.
Oh yeah, I
You gave it to
Wait, okay, let's check.
Yeah.
Okay, let's check this. Okay, 1, 4, let me just write this once again. X equals 0 to Y, Y equals to negative Y over 7, minus X e to the negative Y over 7. The first thing to respect to X, okay.
What? Why is it worse? Oh, up there is a typo? Oh, okay. There's a typo.
First
It's
one,
double
we
it,
integrate
no,
with respect to X, so that's simple enough. E to the negative Y over 7 minus X squared over 2 e to the negative Y over 7. We are evaluating this between 0 and Y. 49 goes from 0 to infinity. Plug in what Y is, so you get Y squared e to the negative Y over 7 minus Y squared over 2 e to the negative Y over 7. When I plug in X equals 0, I get 0 here, I get 0 here. So and it's nice that they're basically the same terms, so I just get 1 of this minus 1/2 of that, you just get 1/2 of that, so 1 over 2, 13 to 0 to infinity, Y squared e to the negative Y over 7. That's So it's just that in this you have to do integration by parts twice. That's some work, but that's not too bad.
Put it on the third line over there. Isn't it line over 2? Oh, okay.
So y squared is negative y, well, 7, negative 7, 0 to infinity, minus plus 7, 0 to infinity, 2y into negative y over 7 dy. When I plug in, as y approaches infinity, e to the negative y over 7 goes to 0 faster than this goes to infinity. That's 0 minus, when I plug in 0, I get 0 again. So I can ignore that.